This is a quick reteaching video on finding missing angles of quadrilaterals, specifically parallelograms, rectangles, rhombi, and squares. So pay very careful attention and write in your own worksheet as you follow along. We can pause the video at any time. So this figure is a parallelogram. Angle DCB, the entire angle DCB is 64 degrees. ADB is 71 degrees. ADB is just this small piece here. And angle CAB is 25 degrees. And now we need to find the other missing angles. Before I even look at these angles, I'm going to figure out the ones that I don't have. So since this whole angle is 64, opposite angles are congruent, so angle DAB would also be 64 degrees. We already have 25 degrees of that. So 64 minus 25 equals 39 degrees. So DAC is 39 degrees. Together, these two angles must add up to the opposite angle, which is 64. Now, in order to figure out this missing piece, we need to know how many degrees total angle ADC is. Well, these two angles are on the same side of their supplementary. So if I do 180 minus 64, I get 116 degrees. This entire angle in the corner, and also here because it's opposite, is 116 degrees. Since we already have 71 degrees of it, 116 minus 71, 45 degrees. So here we check DCA. DCA would be alternate interior with the 25 degrees. So DCA, 25 degrees. Angle DBA, DBA, alternate interior with 45. This would be 45 degrees. Angle DAC is 39. And angle ABC, the entire angle, was 116. So there's your parallelogram. Continuing on to the rectangle, we know that all corner angles of the rectangle are 90 degrees total. Angle ACD is 23 degrees, so ACD 23 degrees. The rest becomes simple exercise and subtraction. So this corner is 90, so if we want this piece, 90 minus 23 will give us 67, excuse me. Then these two angles, alternate interior, so I can go alternate interior, 23 in this corner, 67 in this corner. And then we need to remember that since the diagonals of a rhombus are congruent and bisect each other, these are isosceles triangles. And in isosceles triangles, the base angles are congruent. So if this angle is 23, this angle will be 23. If this angle here is 23, BAR, then ABR will be 23 degrees. And then we have the same corners as we had before. So this would be 67 and 67. And if you want the middle angle, again, all triangles add up to 180 degrees. So if I want angle DRC, 180 minus 23 plus 23 is 180 minus 46. That would make DRC 134 degrees. This is vertical to it, 134. And these two are a linear pair. So 180 minus 134 would equal 46 degrees. So if we want to fill in the angles that we're being asked for, angle ABC is the entire corner, 90 degrees. Angle ACB is here, 67 degrees. Angle DBC also 67 degrees. And angle ARB 134 degrees. So rectangles are a little bit less complicated than parallelograms. There's fewer pieces of information. Okay, let's go to the rhombus. For the rhombus, remember diagonals are perpendicular, so all four angles in the center where the diagonals intersect are right angles. And angle ACB is 41 degrees. Also, referring to your quadrilaterals notes, you know that the diagonals of a rhombus bisect the angles, so as soon as you know one half of the angle, you know the other half immediately. If I know both pieces here, I could figure out this entire angle in the corner. The whole angle would be 82 degrees. And then this angle would equal 180 minus 82, which would be 98 degrees. Since opposite angles are congruent, each small piece would be 98 split equally in half. So 98 divided by 2, 49 degrees for each of these, and the same here. So a rhombus should be one of the easier quadrilaterals, parallelograms to find missing angles for. Another way you could have done this is because this is a right triangle, and all so there you have 90 degrees, and all triangles add up to 180 degrees. Simply add 90 plus 41. Subtract from 180, and that would have also given you 49 degrees. So angle DAB is 82 degrees. Angle ABC, 98 degrees. Angle AEB, 90. And angle CDB is 49. And then finally, the easiest shape of all is the square. And we know that, again, all the corners are right angles. The diagonals are perpendicular. The diagonals also bisect the angles. So if we bisect a 90-degree angle, it is always going to be 45 degrees in each section. So angle ABC, 90 degrees. Angle ACD, 45 degrees. And angle ABD, 45 degrees. So when you do these problems on a test or a quiz or an exam, you need to make very sure that you're writing the correct degrees for the correct angle. So it helps to take a highlighter. Angle ACD, you can see, is the 45. Angle ABD is again a 45. So hopefully this helps. You can watch this video as many times as you like to study for your upcoming test and exam.